Alrighty. The following is going to be a two-part lecture on first the center of mass of a region, and secondly the moment of inertia about the center of mass of a region, so a perpendicular axis going through the region at its center of mass. Alrighty. So first of all, let's begin with our region. So we're going to have between x is equal to -1/2 and x is equal to 1. We're going to have the two functions. One is going to be y is equal to x, and the second y is equal to 2x squared minus 1. Now, our -1/2 and 1x bounds are actually going to be where these two functions meet. And if you didn't know that, you could just plug them into our functions. Or if you were actually having to find where the two functions meet, you could have just set them equal to each other and solved for when x is equal to 0. But we don't have to do that. So we have -1/2 to 1. Alrighty. Whenever we plug in -1/2 for x, it's just going to be -1/2, of course. Whenever we plug in -1/2 for our for our quadratic function, it's also equal to -1/2. Alrighty. We'll go ahead and plug in a middle point too. So we have, whenever we plug in for our linear equation, it's just going to be equal to 0. Whenever we plug into our quadratic equation, it's going to be equal to -1. So we have this little outline so far. And whenever we plug in Wonder equations, we get 1, and then we also get 1 again for our quadratic equation. So that is where they meet. And now we have a little picture of our region. Alrighty. So for the first part of the lecture, we're just going to find our function's center of mass, which is traditionally given as a point x bar comma y bar. And our x bar, our x value center of mass, is going to be equal to the integral of our average x value multiplied by dm, our little small piece of mass, is going to be over the integral of our little small pieces of mass. Y bar is going to be the same, except it's going to be the average y value, so we have this equation. Alright, so let's start off with finding our three necessary things: our average x value, our average y value, and then our little small strip of mass. Alrighty, we're going to do that over here. And for this problem, since our functions are in terms of x, let's go ahead and make a vertical strip with a width of dx. And this is going to be our example little segment of dm, our little small segment of mass. And, alright, I'm sorry, I did forget one very important part of the problem. It's going to be rho is equal to x squared, or density is equal to x squared. So, first of all, we have our top function y equals x, and our bottom function 2x squared minus 1. Alrighty. And then now let's go ahead and figure out what our dm is equal to. And this is a dm strip, so we're going to label it dmt. And it's equal to our dA times our density. And then now we have our dA, which is our little small piece of area. which is going to be this little section right here. And it's going to be a little rectangle with a width of dx. And it's going to be multiplied by a height. And our height is actually, in this case, going to be our top function minus our bottom function, which is just going to be negative 2x squared plus x plus 1. Alrighty, and then our DMT, our DM strip is going to be equal to our dA area multiplied by our density. In our case, our density is going to be x squared, so we can just distribute an x squared out into a function. So we have negative 2x to the fourth plus x cubed plus x squared dx. Alright, so now we need to find our average x and our average y value. And we made a vertical strip, which only has a width of dx. So for our average x value in this little strip, it's just going to be x, because it's an infinitely small strip. So our average x value in the strip is just going to be x. Now, our average y value is going to be the average of our top minus our bottom. Then we have our average by adding, or generally we find an average by adding two things together and dividing by how many terms there are. And in this case, we have two terms, and we're going to use the function, or their functions. So we're going to have x plus 2x squared minus 1, because they're being added together, and it's all going to be over 2. So that's our average y for our little strips. Alrighty, so now let's see, what do we have in both equations that we go ahead and solve for? Well, our integral of dm over our bounds. So, and keep in mind, in this part of the problem, the integral of dmt is going to be equivalent to our integral of dm, at least in our general equations. So we have the integral of negative 2x to the fourth plus x cubed plus x squared, and it's going to be from negative 1/2 to 1, and this is all going to be with respect to x. And also keep in mind the integral of our little mass strips is just going to be equal to the total mass of the region, which is generally denoted as capital M. So we will go ahead and denote it as so. And this function is actually already integrate, or we can find its antiderivative. So we have negative 2 x to the fifth over 5 plus x to the fourth over 4 plus x cubed over 3 and then we have dx or sorry, not dx. We have evaluated from negative 1/2 to 1. Alrighty, so this is negative 2/5 plus 1/4 plus 1/3 minus, in brackets, -2/5 times -1/2 to the 5th plus 1/4 times -1/2 to the 4th plus 1/3 times -1/2 to the 3rd. And we'll go ahead and we can plug this expression directly into our calculators. To make it a little bit easier to plug in, we'll go ahead and distribute our negative out. So we have this turns into a plus, this turns into a minus, this turns into a minus. All right. And now we can plug this expression directly into our calculator. So we have, alrighty. And then we get 63 over 320. And then now we need to remember to multiply. Sorry, not multiply. Now this is equal to our mass, which is just our integral of dm. Alrighty, so now we can insert this into our other equation. So we'll start off with our center of mass x value. So this is equal to the integral of our average x value, which is just x, times our dm strip, which is in this case -2, 2x squared minus it's going to be x minus 2x squared plus 1 and then that's going to be the integral, I'll reset. Alright, 3, 2, 1, go. Alright, so then we're going to solve for x bar, which is equal to the integral of our average value of x, which is going to be x in this case. And then our dm, which is going to be equivalent to -2x to the 4th plus x cubed plus x squared dx, and dx is surrounded by the whole entire thing, and this is going to be over our integral of dm, which we solved for earlier, and we got 63 over 320. Yep, we have 63 over 320, and then now we can rewrite our x bar equation. And then now we can rewrite our 63 over 320 as 320 over 63 times our integral from -1/2 to 1 of, and we'll go ahead and distribute our x out, so this becomes -2x to the 5th plus x to the 4th plus x cubed and that's dx. Alrighty, and then now we have 320 over 63, and now we can actually solve our antiderivative. So this becomes negative 2x to the 6 over 6, which becomes negative 1/3 x to the 6th plus x to the 5th over 5 plus x to the 4th over 4, evaluated from negative 1/2 to 1. Alrighty. And now we can plug our values in, and we get this is equal to 320 over 63 multiplied by negative 1/3 plus 1/5 plus 1/4 minus negative 1/3, which turned, and we'll go ahead and we'll distribute our minus as we're going through this. So negative 1/3 x to the 6th, or sorry, negative 1/2 to the 6th, and that becomes positive 1/3. And then our second term, we'll go ahead and distribute it all the way out. So our second term will become negative, and our third term will also be negative. So this is 1/5 x, or negative 1/2 to the 5th minus 1/4 negative 1/2 to the 4th. And now I can go ahead and plug this into our calculator. So I'm going to go ahead and do a skip until I've plugged everything into my calculator and got an answer. Alrighty. And for this we get 9 over 80 multiplied by 320 over 63. And then whenever we multiply that out, we get 4 over 7 is equal to x bar. Alrighty. And then now we can go ahead and solve out for our y bar. So we have y bar is equal to our average, or the integral of our average y value, which is x plus 2x squared minus 1 over 2 times dm, which is going to be, if we look back up here to make sure we get it correct, negative 2x to the 4th plus x cubed plus x squared dx. And then we'll actually go ahead and pull out this 1/2. And then this is all over 63 over 320. So this is going to be equal to, we can bring up our 320 over 63, which turns into 160 over 63 times the integral, and I'm sorry, negative 1/2 to 1. Differentiating with respect to x over the region. And then now all we have to do is factor out our two expressions, and we can go ahead and do that in this. So we have negative 2x to the 5th plus x to the 4th plus x cubed minus 4x to the 6th plus 2x to the 5th plus 2x to the 4th plus 2x to the 4th minus x cubed minus x squared. This is all dx. We can go ahead and now rewriting our next term, we can simplify a couple of things. We'll start off with our highest term, negative 4x to the 6th. We have our x to the 5th term, negative 2x to the 5th, positive x to the 5th. Those two cancel out. We have no more x to the 5th terms. Now we have x to the 4th, 2x to the 4th plus 6 to the 4th plus x to the 4th, that's 5x to the 4th. We can go ahead and underline those. And then x cubed minus x cubed is 0, so those two cancel out. And this is just minus x squared dx. We can now solve for an antiderivative, and for this we get 160 over 63 multiplied by negative 4 times x to the 7th over 7 plus x to the 5th minus x cubed over 3, evaluated from negative 1/2 to 1. Alrighty, and then now we have, this is equal to 160 over 63 multiplied by negative 4/7 plus 1 minus 1/3 minus, I'm going to go ahead and distribute this as it comes, so it's turned into a plus. Our first term is going to be a positive, our second term is going to be a negative, our third term is going to be a positive. We have negative 1/2 to the 7 over 7 plus negative 1/2 to the 5th times negative 1/2 cubed over 3. And now, once again, I'm going to go ahead and skip until after I have added these all together in the calculator. Alrighty. And then for this, we're going to get 9 over 112 multiplied by our factor, 160 over 63. And whenever we multiply this out, we get 10 over 49 is equal to y bar. This brings our center of mass to the point of our x bar, which is 4/7, comma, 10 over 49. And that is our center of mass of our region. And in the next video, we're going to be figuring out the moment of inertia about the center of mass. Alright, thank you all for watching.